Okay, so today we are talking about y-intercept and initial value. It's our objective is I can identify and interpret the meaning of the y-intercept or initial value of an equation. Okay, so my learner's question is going to be simple. How can I identify and interpret the meaning of the y-intercept / initial value? Okay, so the very first thing we have to do is identify the difference between the y-intercept and initial value, and surprise, there isn't any, okay? Okay, it's the same thing. Okay, so when you hear y-intercept, you hear initial value, those mean the same thing. Okay, so review. What do the m and the b represent in y equals mx plus b? Okay, well, if you remember, m represents the slope or the rate of change. Okay, remember those two words are interchangeable. Okay, and then b is y-intercept or initial value. Okay, that's why when I have y equals mx plus b, it's called slope-intercept form. Okay, not slope y-intercept, but slope-intercept form. Because I have the slope and the intercept. Okay, and specifically the y-intercept. Okay, so remember, y-intercept, I'm going to go back up here. The y-intercept is the point, and I'm going to cross out point, and I'm actually going to change that to y value. The y value, okay, where the line crosses the y-axis. Okay, the y value where the line crosses the y-axis. Okay, so if I'm looking at example number 1, okay, and I'm looking at this y-intercept right here, okay, well on that one, my y-intercept is 0. Okay, that's pretty easy. I would say b equals 0. Okay. On b, I'm looking here, okay, and I'm noticing these are going by ones. So 1, 2, 3, 4. So that's 4 right there. Remember, it's the y value. So on the y-axis. Okay, so on here, my y-intercept equals 4. Okay, and it'll be important to keep track of that your y-intercept is b when we start looking at graphs and writing an equation from them, which we'll do tomorrow night. Well, I guess Monday night. So C is here. This is where the y-intercept is. Okay, so it's hard to tell because there's no numbers down here, but if you look up here, these go by ones, which means these have to go by ones too. But I'm going below 0, so that's -1, -2, -3. Whoops, and then I wrote -2. -3. Okay? So my b on this one, my y-intercept is -3. Okay? I didn't write it in this box over here. Okay? Okay, go ahead and do the 2 U-try problems identifying what the y-intercept of the line is. Okay? Okay, so now we're going to look at example number 2. Identify the y-intercept of the equations below. Okay, so I'm going to write out, I'm noticing that these are in slope-intercept form, so I'm going to write out y equals mx plus b. Okay, so that's my slope-intercept form. Okay, so I'm looking for the number without the variable, not on this side with the y. Okay, so the number without a variable. So right here, that is my y-intercept. Okay, so on example number 2, letter A, my y-intercept is 3. Okay, now I'm going to look at B. B looks a little bit different. I have a subtraction sign. Okay, my form is plus B. So in order to have that subtraction sign there, that means that B had to have been negative. because when I wrote it out like this, y equals x plus -6, well, remember, we don't like to have plus a negative, so we just change that to y equals x minus 6, because adding a negative is the same as subtracting, okay? So here, my y-intercept is -6, okay? Okay, go ahead and do the U-try number 2. Okay, example number 3. The line models the total amount of snow on the ground during a snowstorm. A says, what is the y-intercept of the line? What does the y-intercept represent? B says, what is the slope of the line? What does the slope represent? So we're actually going to add in this, what does the slope represent? Okay, so first let's start with what is the y-intercept. Okay, so my y-intercept, remember, is the y value where the line crosses the y-axis. So here's my y-axis. Okay, here's my line. Okay, and this is about snowfall. Okay, the amount of snow that is on the ground. Okay, so there, right there, is my y-intercept. So that's 3. Okay, what that means is that when it started snowing, so at 0 hours, there was already snow on the ground. There was already 3 inches of snow. So it had already snowed maybe a day before or however long before this was started to be calculated, and then it started snowing more. Okay, so the y-intercept represents, okay, when it started snowing, not showing, snowing, there were already, yes, there was already 3 inches of snow on the ground. Okay, and the reason that I know it's inches is because it's on that y-axis, and the label on my y-axis is inches. So I know that this is 3 inches, and it's at time equals 0 hours. Okay, so when it started snowing, so that's the very beginning of the snowstorm. Okay. Okay, now I'm going to look at the slope. So I'm going to identify the slope, which is the rate of change. Okay, that rise over run. Okay, that we've been talking about. Okay, so when I go from this point to this point right here, I go up 1 and right 2, which is a positive 2. So positive 1, positive 2. So my slope is 1 over 2. Now, remember, this is, technically it's 1/2. Now, it is for 2 hours. It's 1 every 2 hours, but that means every hour, okay, if it's 1 inch every 2 hours, that means that if I divide that, I get 1/2 inch per hour, okay? So that means that every hour, 1/2 inch of snow fell, okay? So every hour, because remember, slope is for 1, okay? So every 1 hour, okay, it snowed 1/2 inch. Okay, so every hour it snowed 1/2 inch. This is kind of hard, okay, but just think about, remember, slope is always a rate, okay? It's always that rate of change. How much does it change each hour or each minute or each second or for each person, whatever. Okay, now, there is a line on here because we're talking about time, and it's not like all of a sudden, after the first hour, 1/2 inch of snow fell on the ground. Okay, it was constant. It was constantly happening. Okay? Okay, go ahead and do the U-try.